Hi folks, we're going to take a look at page 326, number 16. So here they're asking us to find a unit vector in the direction opposite of a vector PQ, where OP, in other words, the origin to point P, that vector is given by 1119, and the vector to point Q is given by negative 21. All right. So let's recall here, and I'm not going to bother drawing a Cartesian plane because I'm just going to use this as a reference. But here, if I have point P, and here I have point Q, okay, and I'm looking for this vector as a guide. Of course, this is not the one I'm actually looking for, but let's recall how we determine this vector. If you imagine that you have your origin there, and there's your vector OP, and there's your vector OQ. Okay, this vector represents the subtraction of these two vectors. Okay, but we have to make sure we do it in the correct order. Okay, because here we're going from P to Q, so we know that this needs to be the tip of the second vector to the tip of the first vector. So we recall that vector PQ is given by OQ minus OP. Okay, so just a reminder how we got that. So let's find the vector PQ. All right, so here let's subtract the x components. So here we've got 2 minus 11 is negative 9. And then here we have negative 21 minus 19. That's going to be, I guess, negative 40. So this is the vector PQ. Now we're looking for a unit vector, so we're going to have to do some work here, but we're actually looking for a unit vector not in the direction of PQ. We're looking in the direction opposite to PQ. So in other words, what we're interested is actually the vector QP. And of course, we know the opposite of a vector is just given by taking the negative of each of the components. So that would just be 940. I don't have to recalculate it. I certainly could do that. But because these are opposite vectors, I just take the negatives. And now we have to remember how we take a vector in any direction, okay, and turn it into a unit vector. And the way in which we do that is to multiply it by 1 over the magnitude of that vector. Okay. So here we just have to calculate this one here. Let's do it. Okay, so here let me show some work. So we know that the magnitude is the square root of the square of the components. So let's see what that gives us. 9 squared plus 40 squared. And we'll take the square root of that. I'll do that by going exponent 0.5. Oh, and it's actually a nice number. So that's why I'm going to leave it in exact form. Of course, I'm multiplying this by 940. So that's just 1 over 41 times 940. And of course, this now is a scalar multiplication. So if I want to write this in the simplest possible way, I'm just going to multiply each of the components by this scalar multiple. So it looks like it's going to be 9 over 41, okay, and then 40 over 41. And there's my answer. Okay, now you could check if you want to, really check to see that you did this correctly. Let's find the magnitude of this vector. Okay, so let's take the square root of, so we'll do open bracket 9 divided by 41 squared, and then plus 40 divided by 41 squared. Let's take that, and there you go. The magnitude is equal to 1, so we know, pretty sure we got the right answer there. Okay, so just to recap. Step number 1, I found the vector PQ by subtracting OQ minus OP. Then I found the vector opposite to that, because that's the direction I'm looking for, by just taking the negative of both of the components. And then in order to find the unit vector in that direction, I just multiplied by 1 over the magnitude of that vector. Okay, that's it for this one.